Okay. So unit 2. Okay. Hmm. The last time we did polarization, we did everything else as well. You guys have any questions, let me know. Today we will move ahead towards, I believe, the next. Wait a second, let me start that up. Okay. So now, today we'll start with the first of all principle of superposition. Now, for this one, I want to tell you the definition. This superposition state. Now, because it's a 2 mark definition, so I'm going to give you 2 marks how to write that. The first part you're going to write it as the when two
Sir, your voice is cracking.
individual. Okay, okay, wait. Let me fix that. Wait, but hmm. Okay, kids. Is it okay now?
Yes.
Okay. When two individual waves meet at a point, their sum of individual displacements, number two, is equal to the resultant displacement of a wave formed at that point. Now, what it means is, suppose that there is a wave like this, and there's another wave that's also like this. One wave has an amplitude 2a, and the other wave has an amplitude of just a. So if they meet together at that point, the result of this will be that they're going to form a bigger wave, and that would be 2 plus a, 3a amplitude. Do you guys understand that?
Yes, sir.
Okay, very good. Now, think about it this way. You can write this down, and then I'm going to move forward. Oh my God, that's great. You guys done writing? Should I go forward?
Yes, sir.
Yes, sir.
Okay. So then you will have two types of interferences. It is called constructive interference, and then we got destructive interference. Constructive interference means that there is a wave like this, suppose it has an amplitude A, and then there's another wave that is exactly like this, and both of these waves are in phase. When I say in phase, which means they have a phase difference of 0 degrees, 360 degrees, 720 degrees, and so on, right? We learned about phase difference, and when I say they're in phase, that means they don't have any phase difference, so they're 0 and 360 multiples. Is it clear? Now, if they meet at any point, what they're going to do is they're going to create a bigger new wave. So now the result will be an amplitude of 2A. So this is called constructive interference, right? All right. Now, in destructive interference, what happens is there is a wave which has an amplitude. Oh my God, where did it go? Okay, never mind. I don't know what happened. Okay, so there's a wave which has an. Oh my God. Wait, I think there's some issue. There's a sibling. There's a wave like this which has an amplitude A, and then there is another wave which is exactly these two are anti-phase to each other. Anti-phase means they have phase difference of 180, 540, 900, and so on. Right. So the amplitude of this one is gonna be minus A. So if they meet somewhere, they're gonna completely cancel out each other. Get it? Yes, Aisha, Daniel, Chavez, Muhammad Rida.
Yes, sir.
Yes, sir.
Right. Now, it's not like they would always do that. Basically, principal superposition will be followed, which means now it could also be possible that one wave is like, let's suppose, 2A, and the other wave is like anti-phase, but it is just negative A. So the result of this can be destructive, but then some of the wave will remain. You guys understand that? So A will remain. So it basically follows principal superposition. But the important part is if you want to really know quickly whether something is in phase or out of phase, oh, sorry, anti-phase. In phase means that the crests of wave are going to overlap and troughs of waves are also going to overlap. But when it is anti-phase, the crest will overlap with trough and trough will overlap with crest. So that's why they're canceling out each other. So that's a quick way of looking at it. Understood?
Sir, can you explain this part again? The one that you
Yes.
just did?
In constructive interference, crests and troughs, crests are aligned with crests, right? You see? And troughs are aligned with troughs. Understood? So trough meets trough, crest meets crest. Get it, Rida?
Yes, sir.
In this one, crests and troughs are aligned over each other, which means that crest is combining with the trough. That is why the cancelling is happening. Understood?
Yes, sir.
Okay. Draw this, please, so we can go forward. When you're done, let me know so I can go forward, please.
Done, sir.
All right. Very good. Very good. Okay. Now, if that is the case, then we can then see that a direct effect of interference is basically into formation of stationary waves. Now, stationary waves or standing waves are basically the same thing. Now, stationary waves are formed when there are four conditions for it. Number one, two waves are traveling opposite to each other along the same line with same speed and wavelengths. When they combine, they're going to form a stationary wave. Is it clear, kids? I'll explain what stationary wave is in a bit. You can write this down first. So basically, stationary wave looks like this. It's a wave like that, and then it forms a pattern like this. Is it clear, kids?
Yes,
In
sir.
a stationary waves, these points are called nodes, and these points are called antinodes. Again, this will be a node generally written as N, capital N, and these points are antinodes written as A, the middle point between two nodes. Now, first of all, we want to learn what is the difference between a node and an antinode. So, speaking of it, nodes have no energy and no amplitude. This is what nodes have. Antinodes have maximum energy and maximum amplitude. So these are moving, nodes are not moving at all. Understood?
Yes, sir.
Very nice. Okay. So now let's go forward. Huh? Speaking of this, then, if you look at if I just draw one portion of it, of a stationary wave, so obviously this will be the node. This is also a node. This is also a node. This is an antinode, and this is an antinode as well. Now check this out. If I find the distance between a node to a node, it's basically half the wavelength. Do you guys understand that? So node to node distance is half wavelength. Also, if you see between an antinode, this is a quarter wave, and then another antinode, this is also quarter wave. So antinode to antinode is also equal to half wavelength. Get it, kids?
Yes, sir.
But if you just check the distance between a node and an antinode, which is this much, so that's basically just a quarter wavelength. Out of everything in this chapter, this is the most important thing that you should be remembering. Write it down, please. I hope you guys understand, right?
Yes, sir.
Yes, sir.
Okay. Now, without understanding that what is the difference between a normal progressive wave and a stationary wave, we won't be able to do much. So I'll go and visually we will see what is the difference. So I'm gonna draw, and you should do 5 lines like this. 1, 2, 3, 4, and 5. Okay. And then you guys need to basically draw another one right here. Okay. This is progressive wave, and this is stationary wave. Now, I want you guys to focus first. Don't draw it yet. I will give you time to draw. But for now, let's suppose there was a wave that was generated at time when it was 0. So just start it, right? When a quarter time period passed, so a progressive wave would would mean that a quarter of that wave has gone forward. Is that clear?
Yes, sir.
When half time period was passed, the next quarter, because half is 2 quarters, so it means 2 quarter wave has gone forward now. When 3 quarters time period passed, it means that about 3 quarters wave has gone forward. And when 4 quarters, which is a full time period, has gone past, it means a full wave has now gone forward. So you can check it like that as well. 1 quarter, the next half wave, 3 quarters, and a full wave has passed till this. So this whole wave is now fully passed at the forward. Do you understand that? Like that.
Yes, sir.
So every quarter time period, you can see the wave moves a quarter forward. It's basically moving the energy forward. This is called progressive waves because they are progressing, or there is a progression shown in terms of energy. Now, standing waves are quite different because so in a standing wave, we have fixed nodes and antinodes. As we learned previously, that nodes have no energy and antinodes have maximum energy. So if at time t0, the wave looks like this. So only antinodes can move. That means when the time would be a quarter time period, the node which is right here is going to go down, this one is going to go up, this one is going to go down. So the wave is going to look like just this. Node will stay where they are, antinodes will stay where they are, node, antinode, node, antinode, node. Do you guys understand that?
Sir, can you explain it again?
Yes. This node, as you can see, will come down, right? So after quarter, it will come here. This node is going to go up because it's already at the bottom, so it will come here. And this node will come down from the top, it will come here. Nodes cannot move, only antinodes can move. So it will look like a flat line. You get it?
Yes, sir.
Now check this out. When the time will be passed, that is equal to half time period, this antinode was already moving down, this was moving up, this was moving down. So the new wave would look something like this. Okay, I could something like that. Now you see the nodes, the nodes we're talking about would stay where they are, antinodes would stay where they are, nodes here, antinode, node, antinode, node. Only nodes can move up and down. Do you guys understand that? Now it has reached this point. So now see this. When time has passed to 3/4 of time period, this has gone at the bottom, so it will come up, this will come down, this will come up. So again, it will show you a straight line where you have nodes, antinodes, nodes, antinodes, nodes, antinodes, nodes. Get it?
Yes, sir.
In the fourth quarter, which is the full time period, again, this antinode will continue to move up, this will come down, this will move up. So the wave will exactly look like the wave is gonna exactly look like the first one that we had because it has completed one whole oscillation, right? Now, if you basically look at the difference between two, the standing wave is not moving anywhere. It is just going up and down, whereas progressive wave is transferring energy from one point to another. Understood?
Yes, sir.
You can draw this now. Aisha, do you get it? Mohammed, Daniel, Chavez, Ahmed.
Yes, sir.
Yes.
Okay, very nice. Very, very good. That's good. All right.
Done, sir.
Very good. Now, kids. Now, basically, you guys need to understand that progressive wave has crests and troughs. This has nodes and antinodes. Each neighboring particle has the same amplitude because, as you can see, the particles they go up and down. They can all of them can go up and down. Only antinodes have max amplitude and nodes have zero. Amplitude vary between node to antinode. What it mean what it means is that as you can see, there's zero amplitude right here, but as you go up, it is little bit more. This is more. This is even more. And antinode will be higher. Then the amplitude keeps on decreasing, and then when it reaches node, it becomes zero. Do you guys understand that? So the amplitude vary in that one. Each particle can have the same amplitude. Understood?
Yes, sir.
Then in progressive waves, neighboring particles have different phase difference, or you could say out of phase. Neighboring particles are always out of phase. Why am I saying this? Because some particles will be like 0 degrees, 1 degree, 2 degree, 3 degree, 90, 180, 270. We have done that before. In this one, between adjacent nodes, all particles have 0 degree phase difference or otherwise 180 degree. Let me just tell you how. If you look at the particles here, you see when all these particles went down, they went down together. They even went up together. So between nodes to the adjacent node, all these particles have 0 degree phase difference. But if you compare to this section, when the particles move up from this one, here the particles move down. So between this, all these particles and all these particles, there is 180 phase difference. So in stationary waves, either they will have 0 degree, which are the neighboring between nodes and nodes. Otherwise, they will have 180 degree phase difference. There is no other value of phase difference in it. All right, kids?
Yes, sir.
Okay. Then the last point that we need to basically be aware of is that progressive waves can be formed at any frequency, and stationary waves are only formed at specific frequencies. And we're going to talk about that. in a bit. So you can write this down, please, these differences, and then we shall go forward.
Done, sir.
All right, very nice. Cool. All right, everybody has written. Daniel, Aisha, Mohammed, Ahmed, Shawais. Do you guys understand
Yes, sir.
everything?
Yes, sir.
Okay. So the first system in which these waves can be formed is basically called two ends closed system. What it means is that let's suppose there is a end like this that's completely closed, and there's another end like this that is also completely closed. The length of this system is L, and we have put a string into it. Let me just copy this because I need that. And then we have put a string like that. Do you guys understand that? It's just like a system of guitar. If you've seen a guitar, I'm sure you have. So a guitar has strings attached here, and the other end of the strings attached there, they're taut like that. So it's a closed system. Do you guys understand that? Now,
Yes, sir.
if you pluck the guitar just once, it's gonna create a stationary wave that basically looks like, let me just show you. It would look like this. It will go up. Oh my God. It will go up and then it will come down. So it will start vibrating up and down like that. Do you guys agree?
Yes.
This end is the node, this end is the node, and this one is the antinode. Because we learned that the node to the node distance is a value. Do you guys know what that is? What is node to node distance?
Half wavelength?
Half wavelength. That means that half lambda, I can put it equal to L. Can I do that, please? So
Yes,
then,
sir.
can I also write lambda equals to 2L divided by 1? Can I say that?
Yes, sir.
This system, the first frequency at which a stationary wave forms is called the fundamental frequency. And we can find that frequency by simply using V equals to F lambda, because lambda will be basically V upon F. So we can simply replace this. This will come out to be V upon F equals 2L over 1. So if I make F the subject, it will be equal to V times 1 over 2L. I'm intentionally writing 1, you should also write it down. All right. This is one formula for frequency and wavelength we can find. Get it? Okay. Now, if I pluck this two times, like, so it will create a stationary wave which is of the next frequency, like that. Is it clear? This is the node. This is also the node. This is also the node. What distance would that be? What do you guys say? Node to node is half
It's going to be a full wavelength, right?
full wavelength. Exactly. Well, it looks like a full wave, right? Full wavelength. So I can say in this one, lambda is equal to L, right? If that is the case, then can I say if I write 2L over 2, would it make any difference? Can I do that, please?
Yes, sir.
Just for fun. Okay. It doesn't matter because 2 and 2 will cancel out, it will be 1. Right, Aisha? Do you get it?
Yes.
Now, frequency then will be V times 2 over 2L. I've just put 2 here. That's it. All right. You can also use this formula. V is equal to F lambda to find it. It's fine. Then, if I pluck it 3 times, so what will happen? Let's see. There's going to be one wave, two humps, and half, like that. So 3 times would create a wave like that. Now, this is a node, this is a node, this is a node, and this is a node. This is half lambda. This is also half lambda. This is also half lambda because node to node distance is half lambda. So what that might be? 3 by 2 lambda equals to L. So lambda then will be 2L by 3. You guys agree? And if I want to find the frequency, it will be F equals to V times 3 over 2L. You can use V is equal to F lambda to find that. Get it, kids?
Yes, sir.
Now, if you look at the whole thing that I've done, you might be surprised to see that each one of these has 2L on top, 2L, 2L, and every time I go to the next frequency after fundamental, I have the first one, then second one. Every time I go there, it will be 1, 2, 3. You see? So I can basically write a general formula for this, which means if I want to find lambda, it will be 2L by n. And if I want to find the frequency, it will be, you see, 1, 2, 3. Everything remains the same. So it will be V times n over 2L, where this n is called number of harmonics. Harmonics means the number of frequencies that can be generated. And it starts with 1, 2, 3, 4, and so on. If I say you got to find 1000th harmonic, so you can put 1000 place of n and you can find that. Is it clear? You guys get it?
Yes, sir.
So it's that simple, right? So you guys can write it down, please, and then we shall go forward. Now remember that this formula that I have basically derived, you guys need to learn this because a lot of questions you won't be able to do unless you know that this formula belongs to two ends closed system. So that's the tricky part in this. Just got to learn that either by practice or by heart. It's your choice. When you guys done, let me know.
Done, sir.
Done. Very good. Excellent job. All right, kids. So, Aisha, you done? Daniel, Ahmed, Mohammed.
Yes, sir.
Yes, sir.
Yes, sir.
Very nice. So, I will then now see you tomorrow. We have a class tomorrow. Yes, we do. So then we'll shall complete this. All right, kids. So
Okay.
have a nice day then. Bye.
Same to you, Allah Hafiz.
Allah Hafiz.
Allah
Thank
Hafiz.
you, sir. Allah Hafiz.